Dear students, welcome to the session of NEET Bytes. So I hope all of you are doing good. So today we're going to study about magnetism. And yes, hello Meghna, Jinsi, Prashant, Singh, Taranpreet, Technical Gyan, and Santosh. All of you welcome to the session. Yes, we'll have some objective questions. Singh, Taranpreet, hello Kajal, welcome to the session. Hello Ishan. Now let's begin the magnetism 2. So yes, we'll have some of the questions that have appeared in NEET and or AIPMT in earlier days. Let's begin now. So the question is, a long wire carrying a steady current is bent into a circular loop of 1 turn. The magnetic field at the center of the loop is capital B. It is then bent into a circular loop of n turns. The magnetic field at the center of the coil of n turns will be. So earlier we had a loop having 1 turn. Okay. Let us say the radius of this loop is capital R. So as you all know, the magnetic field at the center of the current carrying circular coil is given by this formula, mu naught I divided by 2 capital R. If I is the current flowing in it, this is the value of magnetic field at the center of the coil. So yes, this is the value of B. It is then bent into a circular loop of n turns. The magnetic field at the center of this coil of n turns will be. So suppose we transform this into another coil having n number of turns. Like that. So firstly, how to find the magnetic field? Before finding the magnetic field, we need to know the value of the radius. How to find the radius? Length doesn't change. Length of the coil remains same. So initially, if you talk about the length of this coil is 2 pi r. The length of this coil is 2 pi into capital R. Let us say the radius of the smaller coil is small r. Okay. Radius of second coil P small r. So we have n number of turns. So we can say total length is equal to 2 pi into small r multiplied by small n. So from this, what I can do, I can equate these two values of the length. So when you equate them, you get 2 pi r is equal to 2 pi into small r into small n. So from here, we get small r to be equal to capital R over small n. This is the value of radius of the coil having n number of turns. So what is the magnetic field now? Magnetic field is now, let's say B dash, at the center of the coil. B dash is equal to mu naught Ni divided by 2 into small r. So when you substitute the values of small r, you get mu naught Ni divided by 2 into capital R over small n. This means it's equal to mu naught, we can say it's equal to n square times mu naught I over 2 into capital R. So what is this? This is the initial magnetic field of the previous coil. So we can say it's equal to n square times capital B. So B dash is equal to n square times capital B. So that means the correct answer for the given question is D. I hope all of you are able to understand that. Let's move to the next question. An electron is moving in a circular path under the influence of transverse magnetic field of 3.57 into 10 to the power of minus 2 Tesla. If the value of E by M is 1.676 into 10 to the power 11 coulomb per kg, the frequency of revolution of the electron is. So we have to find the frequency of revolution of the electron. So electron is revolving in a circular path. Why? Because of magnetic force. Because the magnetic force is acting as a centripetal force. That means at every moment, at every point, you can say the direction of magnetic force will be towards the center. So what is the magnitude of magnetic force? Magnetic force is equal to QV Q into V into capital B. Or we can say it's equal to QV cross B. And here if you observe V and B, they are perpendicular to each other because it's given that the transverse magnetic field. So QVB is the magnitude of magnetic force. And that's equal to mv squared by small r. And from this, we can say, we can just cancel out V and V. And we can say V by R is equal to QB over small m. So yes, Q by m for the electron is given, and the magnetic field is also given to us. And what we have to find the frequency of revolution. Now, if you observe this, the right hand side, V by R, where V is the velocity of the electron, if R is a radius, so V by R is equal to omega. Yes? So we can say QB by small m is equal to omega. Or we can say it's equal to 2 pi f. This implies f is equal to QB by m into 2 pi. So in the question, Q by m is given, B is given. So substitute the values of all this. You can get f to be equal to, now Q by m is given to be equal to 1.76 into 10 to the power 11. And B is given to be equal to 3.57 into 10 to the power minus 2. divided by 2 pi. So 2 into 3.14. So if you calculate this all, you'll get something like 6.28 in the numerator, 6.28 into 10 to the power of 9, and in denominator also we get 6.28. So F is equal to 10 to the power of 9 hertz, and that means it's equal to 10 to the power, or you can say 1 gigahertz. It's equal to 1 gigahertz. So C is the correct option. So let's move to the next question. Yes, the question is, an electron moving in a circular orbit of radius small r makes n rotations. It should be revolutions. Actually, in the question paper also rotation was given, but it should be revolution. Okay, per second. Revolution. The magnetic field produced at the center has the magnitude. So we have to find the magnetic field produced by the electron, the motion of electron. So how to find that? So you know the formula for magnetic field. Magnetic field is given by this formula. Mu naught I over 2R. I is the current flowing in the circular loop. R is the radius of the circular loop. So we can imagine the orbit as a circular loop because electron is moving in that. We can say that with respect to time, charge is being transported in a circular loop. So yes, the radius of the circular loop is, let us say, small r. So it's given now. See, first of all, we need to find the value of I. How can you find the value of current? Current means total charge flown upon time. Okay, so let us say capital T is a time period for the revolution of the electron, right? So let us say omega is the angular frequency, or so we can say omega is equal to 2 pi by t. So by this we can say capital T is equal to 2 pi by omega. Just substitute this value here. So what do you get? I is equal to Q. Now electron is there, so we can write E as a charge of electron, and time is 2 pi over omega. Okay, and further we can write it as E omega divided by 2 pi. Okay, E omega by 2 pi. So how can we find the value of omega in terms of revolutions per second? See, in one revolution, the angle covered is 2 pi. In n revolutions, we can find the angle covered will be 2 pi n. So by 1, by time, this is the value of omega. So for this question, 2 pi n is the value of omega. So that's equal to E into 2 pi n divided by 2 pi. So cancel the 2 pi, you get NE. You get NE as the value of the current. Now, substituting the value of current in the above formula, so what do we get? What do we get? We simply get B to be equal to mu naught I, mu naught into NE divided by 2R. So the correct answer for the given question is option D. Okay, let's move to the next question. Two identical long conducting wires AOB and COD are placed at right angle to each other such that one is above the other and O is the common point. Let's make the diagram first. Suppose this is your y axis, this is your x axis, and this is z axis. Okay. Now, what is given in the question? It is given that the two identical long wires AOB and COD are placed at right angles to each other such that one is above the other and O is their common point. The wires carry I1 and I2 currents respectively. Point P is lying at a distance d from O along a direction perpendicular to the plane containing two wires. The magnetic field at the point P will be. So how to find the magnetic field at the given point? Let's say we draw the two wires. So we have wire AOB and COD, right? So yes, this one, let us say, is your AOB. And this is lying along x-axis. And let us say the other wire is like this. It's lying on the z-axis. This is your COD wire. This is your COD wire. CO and D. So in one wire, what is the value of current? The wires carry current I1 and I2 respectively. So in AOB, the current is like this, I1. And in COD, the current is I2. So we have a point. We have a point above this. We have a point along y-axis, and the distance of point from point O is small d. So dear students, you can apply right hand thumb rule to find the direction of magnetic field at point P. So put a pen along AB and hold it, and you can find using right hand thumb rule that at point P the direction of magnetic field will be in negative Z. This is the value of B1. This is the direction of B1 vector. Talking about the magnetic field due to the other wire COD, just put the your pencil along this, and your thumb along the direction of COD, and you can find that the direction of magnetic field at point P is in the left hand side. That means x-axis. This is B2 vector. So now we can understand that these two vectors are perpendicular to each other. Okay, these two vectors are perpendicular to each other. If you're talking about magnetic field at point P, the two vectors are perpendicular to each other, and we have to find the magnitude. So total magnitude will be equal to b1 square plus b2 square root of that, right? So what is the value of b1 square? What is the value of b1? b1 is equal to i1 mu naught i1 upon 2 pi d, and b2 is equal to mu naught I2 over 2 pi d. If you substitute these values in the above expression, in this expression for B net, you will get the answer to be option D. D is the correct option for the given question. Okay. Sumit, you can see the recording after the class if you can't understand. Maybe you have missed some part. Let's move to the next question. When a proton is released from rest in a room, it starts with an initial acceleration a naught towards west. When it is projected towards north with a speed v naught, it moves with an acceleration 3a naught towards west. The electric and magnetic field in the room are. The first thing to understand is magnetic field can never apply force when the charge is at rest. The charge has to be in motion for the magnetic field to apply the force on it. So, proton was initially at rest. So it starts with an acceleration a naught towards west. This means the acceleration a naught that's coming to the west is only because of electric field. So yes, now we can do one thing. We can make the directions north, north, south, east, and west. So initially we can understand that it's a proton and the direction of acceleration is towards west. That means the electric field must be directed towards the west. Yes, because the force of electric field or electric force on the electron on the proton will be equal to E times capital E, and that is due west. So yes, now apply F is equal to ma naught, where m is the mass of the proton. So by this you can say that capital E is equal to ma naught divided by small e. So this is the magnitude of electric field, and the direction is due west because it is applying a force in the west direction. Now coming to the other case, when it is projected towards north with the speed v naught, it moves with an acceleration 3a naught towards west. Now, when it is moving, two forces are acting. One is electric force and one is magnetic force. Now, what should be the direction of magnetic force? If you observe, you have learned that magnetic force is given by this formula. It's QV cross B. QV cross B is the formula for magnetic force. So Yes, because the acceleration, the total acceleration is more than a naught. That means the magnetic force must be in the west direction. Otherwise, the total acceleration would not be this, right? So the magnetic force is in west direction. So and the velocity is along north direction. So if you apply right hand thumb rule, you can understand that V cross B will be towards west only when the magnetic field is downwards. V cross B will be only in west direction when the magnetic field is in west direction. Oh, sorry, downward direction. So now, as they are perpendicular to each other, we can say QVB, QV naught B plus you say E, sorry, we should write it to be EV naught because E is the charge of proton plus E, and EE is equal to M times 3A naught. And we have learned that EE is equal to MA naught. So this is MA naught. In the above equations, we can see that capital E, small e into capital E is equal to MA naught. So this is equal to 3MA naught. So this implies EV naught B is equal to 2MA naught. That means B is equal to 2MA naught divided by E into V naught. This is the magnitude of magnetic field, and that is in the downward direction. Downward. So the correct answer for the given question is B. So I hope you have learned a lot today. So like this, you just keep on solving questions. So all the very best. Thank you so much for your time. So to know more how we can help you in your preparations, you can just see the given link. Okay. So thank you so much, students.